Moving into our Module 3, we're going to start with 3.1, Graphing and Lines. So we're going to start with an introduction to graphs. In particular, we're going to focus on what lines are and how do we express them algebraically. So to start us off, let's start with the definition of what is an ordered pair. So if I have two real numbers, let's call them A and B, an ordered pair, which we denote within parentheses A comma B, this specifies a point on my xy plane. The first coordinate that we see, A, this is our horizontal position, that is our left and right position on the plane. While the second coordinate, B, this represents our y coordinate or our vertical position, that is where are we up and down on my Cartesian plane. So we're actually going to go ahead and jump straight into an example here. We have example 1. I've got 4 points, and I want you to plot these 4 points. The first point, point A, I have -3, 1. Well, this means in terms of x, my left and right, I want to be at the -3 position. So what I'm going to do is I'm going to start at the origin, and then I move 3 to the left, for example. And then my second coordinate is 1, telling me I must go 1 in the positive direction up and down, or in this case 1 up, giving me my point A. So I have point A. And then for points B, C, and D, I follow the same idea. For point B, I have 2, -4. This means 2 in the left and right direction, and then -4 in the up and down direction. In particular, we have 2 to the right and 4 down. So 2 over, 4 down, 1, 2, 3, 4. We have point B. For C, we have 1, 0. Again, this means 1 in the right direction and 0 up and down. So in fact, I just have this point right here. And then for D, 0, -2, this means 0 left and right, and -2 in my vertical direction, or in this case, 2 down. So I have my 4th point. So I did go through this example very quickly. The particular reason is that these points, there's not much that we're doing with these in terms of just plain points. We just have our left and right direction, and then our up and down direction. So this is how we look at our first example on to plot 4 points, actually. Now let's move into our next example. But before that, remember the title of the section is called Graphing and Lines. We're going to focus on how do I work with a line. So in example 2, graph the line containing these 2 points, 2, 3, and 4, 0. Let's see, the first thing I'm going to do is I have 2 points, and I'm going to plot them. So I have 2, 3, so that's 2 to the right and 3 upwards. 4, 0, that's 4 to the right and 0 units up and down. So I have 2 points. So if I want the line containing these 2 points, then all I'm going to do is let's play a game of connect dots. I'm going to connect these 2 dots, or points, and I'm going to extend this line as far as I can in either direction. So in other words, I get something that looks a lot like what I have here. So again, we connected the dots with a straight line, and then we extended our line. One thing I want to point out is that in math, typically whenever we refer to a line, we're actually talking about a line segment, or a straight line, in other words. Well, in all these examples, notice that my line does not have a curve, it has no turns. That's why I'm able to just connect these 2 dots and extend the line. So if we have 2 points, we know how to graph a line. We just plot the 2 points, and then we connect the dots and extend the line. Now, let's go ahead and look at example 3. This time, same instructions, well, similar instructions. Give 2 points lying on this given line. Y is equal to 2/3 x minus 2. And once again, I want you to graph the line. So this time I didn't give you the 2 points, but I claim that you can give me 2 points. So what I'm going to do is, looking at this equation, notice that this equation says if I give you x, I know what y is. So what I'm going to do is I'm going to go ahead and choose 2 random x values, your 2 favorite numbers, and I'm going to plug them in for x. Well, for me, what if I just choose 2 numbers? Let's say, I don't know, x is equal to 0 and x is equal to 3. Let me choose these 2 random numbers. Let's see what happens whenever I plug in x is equal to 0. Well, I get that y is 2/3 times 0 minus 2. Well, 2/3 times 0, that's 0 minus 2, giving me y is negative 2. So this told me when x is 0, y is negative 2. Remember that an ordered pair is just my x, comma y. Hence, I can write the point 0, comma negative 2. Now, I'm going to do the same thing with x is equal to 3. I'm going to plug in 3 for x, so I get y is 2/3 times 3 minus 2. And I'm going to clean up as needed. 2/3 times 3, that should give me 2. And if I subtract 2, I'm going to be left with y is equal to 0. So I know I have the point 3, comma 0. Now that I have 2 points, I'm simply going to follow what I did in the earlier example. Let's go ahead and plot the 2 points. We have 0, comma negative 2, so it's 0 left and right, and then 2 units down for my first point. And then my second point is 3, comma 0. That means 3 to the right and 0 up and down. So I have something that looks like this. And once again, I'm going to connect the dots and extend the line as needed. I should end up with something that looks roughly like what I have here. I'm going to put arrows on the left and right to indicate that this line does continue to go. So, even though I didn't give you 2 points, you are able to plug in 2 of your favorite x values, plot the points, and once again connect the dots and extend the line. Thus, we are done with example 3. Now, let's go ahead and introduce a new definition. If I look at a line, one way that we can describe a line is by its rate of change. That is, in other words, the slope. So if I have 2 points, P1 defined by x1, comma y1, just some random point on my line, and let's say I have another point, x2, y2. If these are 2 different points on my line, then we can calculate the slope as follows. Slope, which we usually use m to represent slope, this is my rise over the run. Remember that rise, this refers to my up and down change, or in other words, my y2 minus y1. All over my run refers to my left and right movement, or in other words, x2 minus x1. Again, this slope measures our steepness of my line. How steep is my line, or how fast is it changing in the positive or negative direction? So, using this formula for slope, we can go ahead and look at example 4. Find the slope of a line passing through the points -1, 2, and 3, 5. Well, since I have 2 points, I can name one of my points x1, y1, the second point x2, y2. So all I had to do is fill in the blanks for my slope formula. Remember that it's y2 minus y1, in this case 5 minus 2, all over x2 minus x1, in this case 3 minus -1. Now my job is to clean this up. On the top, 5 minus 2, I get 3. On the bottom, 3 minus negative 1. Well, minus negative 1 becomes a plus 1, giving me 3 plus 1, or just 4. Leaving me with 3/4, which is already simplified all the way, giving me my final answer. So again, if I have 2 points, you can calculate the slope pretty nicely. Now, let's talk about the other example, example 5. What if I want you to find the slope, and then I want you to plot the line? Let's graph the line after we get the slope. So here I have find the slope of the line passing through the points 0, 2, and 8, 2, and then I want you to graph the line. Let's start off with the slope. Again, slope, we have y2 minus y1 over x2 minus x1, where I can call this first point my x1, y1, and the second point x2, y2. Just following through with my slope formula, I have y2 minus y1, so 2 minus 2, all over 8 minus 0. Well, you probably noticed what's happening already. On the top, I have 2 minus 2, giving me 0 over 8, which simplifies down to 0. So this does leave the question, what does it mean when my slope is 0? Well, there's a couple of ways that we can look at this. Remember, slope is a measure of how steep my line is. If my slope is 0, that means my line, I'm actually expecting it to have 0 steepness. In other words, I'm expecting it to be a flat line. So, let's see what that looks like. I have the points 0, 2. If I plot that point, that's 0 to the left and right, and 2 upwards. My second point is 8, 2. This means 8 units to the right and 2 units up. So you can't really see it on this graph that I have on the worksheet, but you can imagine that I go 8 units to the right and 2 units up. I'm going to end up roughly somewhere on the edge over here. If I connect the dots, I just have a very long straight line. And this matches what I was saying earlier. Slope of 0, I should end up with a flat line. So, once again, I found the slope and I've graphed the line simply by using the points that I know are on the line. Then we're already done with example 5. Just so that we're exposed to some more functions, or equations, let's look at example 6 now. Graph the linear equation y is equal to negative 5. What is the slope of the equation? So before, each time I gave you an equation of a line, you would pick your favorite x value, plug it in, and get a y value. But if I look at this equation, y is equal to negative 5, this is telling me no matter what x value I use, my y value is always negative 5. So I can choose 2 random x values. Let's say I'm just going to choose, I don't know, let's say negative 2, and let's do 3 for my x values. Well, again, I said no matter what, based off this equation, my y value is always negative 5. There's no question about that. So just from this here, I have 2 points already. So let's go ahead and graph this line. We have negative 2, 5, so that's 2 to the left, and then negative 5 units down, 1, 2, 3, 4, 5. And then I have 3, negative 5. Well, if I look at 3, negative 5, that's 3 to the right, and then negative 5 down. So once again, I connect the dots, and I notice once again, I have a flat line. And this isn't a coincidence. I know what the slope of a flat line is. the slope of a flat line should be 0. And I can actually verify this if I just use my slope formula. So let's say I didn't make that conclusion immediately, just from my drawing. So if I did my y2 minus y1, I would get negative 5 minus 5, all over 3 minus negative 2. You can see very quickly that we do also get 0 over 5, or just 0. So in either case, I can figure out that my slope is 0. This also tells me from this example, if you ever have y is equal to a number, no x's or anything like that, then I am expecting a flat line. Thus, we are done with example 6. We can continue forth into example 7. Graph the linear equation x is equal to negative 3, and then find the slope. So this one looks a lot similar to the one we had earlier. In example 6, we had y was equal to a number, and now I have that x is equal to a number. Well, this tells me no matter what y is, x has to be negative 3. That's what this equation tells me. So this time I can't choose any random x value because my value for x must always be negative 3. So I must always have negative 3 comma something, and my second point must also be negative 3 comma something. Well, since this equation has no y's involved, then I can just choose my two favorite y values. This time let's do negative 4 and negative 1 for my y values. Again, I'm allowed to choose whatever y value I want because my x values will always be the same. If I look at this and plot the 2 points, the first point, negative 3, comma 4, negative 4, sorry. That's negative 3 to the left and 4 units down, giving me something along here. My second point, negative 3, comma negative 1, is 3 units to the left, 1 unit down. Now if I connect my 2 dots and extend the line, I end up with something that looks like, not just looks like, is exactly a vertical line. So this tells me if I have x is equal to a plain number, no y's, then my graph must be a vertical line. But what's the slope of this equation? Let's see what happens whenever I try to calculate the slope. If I use my formula for slope, I have y2 minus y1 all over x2 minus x1. In my numerator at the top, 1 minus negative 4 minus negative 4 becomes a plus 4. So really I have 1 plus negative 1 plus 4, or just 3. On the bottom, you can actually see that I'm going to get 0. Well, we don't want to divide by 0. If this is the case, then I say that my slope is undefined. So we have an undefined slope anytime we have a vertical line. So this is our slope here. So that finishes our example 7. Now, let's look at our last one for this video. Example 8. Graph the line passing through the point negative 1, comma 2 with a slope of negative 2. So each time before, we always had 2 points. But what if I give you only 1 point and the slope? Fortunately, we have a very quick way to understand this and graph it. I have a point, negative 1, comma 2. With a point, I'm going to go ahead and try to graph that point. That is 1 to the left and then 2 units up, as I've indicated here. I don't have another point, so I can't graph that second point, but I do have the slope. And remember, slope, this is an indication of the rise over run. This actually measures from one point on my line to another point on my line. How must I rise and how must I run to get to another point? Well, here we said the slope was -2. And remember, -2 can be written as -2 over +1. This is still -2. But the point I'm going to make here is, if I have a point on my line, to get to my next line, this tells me I must rise -2 units. Or in this case, go down 2 units. So for example, from this point, I'm going to use a blue line to indicate that this isn't actually part of my graph. I go down 2 units. Then I must run 1 unit in the positive direction. If I use 1 unit in the positive direction, that is 1 unit to the right, then my next point should be at the origin. So we can see here, from the first point to the second point I've graphed, I went down 2 units and 1 unit over. Now I have another point. I have 2 points. That tells me that I can graph my line using these 2 points. If I connect dots and extend my line, I should end up with a graph that looks a lot like what I have here. One other thing I want to mention, or 2 things I want to mention, is that I can continue this process for slope to check my answer. I should be able to go down 2 units and over 1 unit and still be on the line. So we can see here, if I move down 2 units and 1 unit to the right, I'm still on my line. And I can repeat that process as many times as I want. I can even go in the opposite direction. I can go 1 unit to the left and 2 units up, and I still have my line. So this tells me that even if you have only a single point and you have the slope, then you are able to graph the line. So this is what I'm looking for as we work with our graphing of lines. And so that finishes example 8 and the last example for this video.